to share my research experience. So let me start my session. Okay, fine. I think it is all visible to everyone.
Yes, ma'am.
Okay. So, as already introduced by Dr. Vikram, this course is going in a very fine track. So, today my contribution is towards information retrieval in data at rest and data in motion paradigm. So, basically, my prime research area is data analytics, big data analytics. So, obviously, I'm going to here. I'm here going to promote this big data analytics environment as a most suitable environment for information retrieval. So this is my motivation for preparing this particular talk, so that I can convince everybody, like with the help of this big data tools, we can facilitate a lot of IR related functions very efficiently. So I have organized this lecture in basically there are two sessions. So I'm going in this particular sequence. First, I will discuss a very brief idea about the information retrieval, whatever is useful for my talk, only that part. So I'm discussing some of the very basic terms. Then I'm starting with the big data fundamentals, and then I will discuss like what are the two different scenarios where we are sailing nowadays. So it is like big data is like ocean, so we are sailing in two different way. So one is data at rest, and second is data in motion. So with the help of these two different directions, I will try to highlight all those aspects where the information retrieval techniques can differ, and that can be addressed thoroughly with the help of available big data tools. So for that, I am taking two very prime scenarios. One is IR using Hadoop MapReduce, and second is IR using Apache Spark. Then I have certain conclusive remarks, like how to go for a particular tool and what should be the motivation when we are going for these big data frameworks for IR related tasks. So I'm starting with the very basic thing. So as you are already aware now, like we see IR as a task where we are trying to finding some materials. So basically it is a kind of document searching in a very vague terms. And you know that most of the time the repositories are too wide, too means basically it is unlimited. So I think you all can get convinced with this idea, like we are having this problem very prominently. Like earlier we were lacking for the information, but now we are droning within this availability of documents, and still we are lacking for information. So this is the current situation. Like earlier we were lacking for information because we were not having enough data available, but now we are still lacking for information because we are having huge amount of data, and we are struggling at various level, like how to store, then how to retrieve, and then how to get knowledge from this particular huge amount of data. So the problems are still there. So IR is a very relevant field where we can see like how this completely changed big data scenario is going to transform the whole process of IR. Okay. So if we talk about in terms of storage capability, so storage capabilities are again beyond our imagination. And if we talk about in terms of user expectations, that is the type of queries. So basically the type of queries are also too wide, like means there are means users are too creative, so we are looking for the queries which are really very intelligent type. So basically, this is the complete new scenario for information retrieval techniques, where the data repositories are growing too fast, and where the user interaction is also very high, and user interactions are also very customized. So how to work well with these two scenarios, and how to work with some very efficient system, so that we can cater the demand of everyone. So if we see for some basic nomenclature, so still the IR is nothing but focusing on some searching techniques so that we can retrieve some data, some information, and we can improve our knowledge. So you can see, as per literature, it was only focused for the textual information, but the present scenario is completely different. Whatever repositories we are looking for, these repositories are not only catering us text, but it is also catering us images, videos, and maybe sometimes some other webcast applications. So basically, these are the resources where we are looking for information retrieval. Then how we what we find most of the time, so most of the time if we are working on text, then we have a huge collection of web pages, PDFs, PowerPoint slides, paragraphs, etc. Okay. uh, so at what level we are operating? So I think for any task which we are doing with computer system nowadays, it starts with searching. So basic, if you are working in your office, or if you are having some internet uses, if you, it is related to your personal search, if it is some enterprise specific task, so everywhere what we are doing, we start our task most of the time by having some kind of searching. And once the search is there, then the next very possible use case is storing. And then third very possible use case is understanding or extracting knowledge from this. So these are the various scales where we are operating. So if we go for a typical information retrieval life cycle, so the first task is source selection. So source selection is if I correlate this with the big data environment, so you can understand that this source selection is having ample opportunities. So for any simple keyword, if you are searching in your Google search, so you can see that there are some results which are in terms of text. There are some other panel maybe at the left side or right side which is showing some image search options, and there may be also certain YouTube video recommendations. So that is very common scenario. So source selection is one thing. Then we have to perform well set of queries. So it is always said that if we are somehow keeping the queries well structured, then there are high chances of getting the particular document. Okay. So but you see, like even whatever queries you are keeping for your searching operations, the collection of document you are getting, it is not very easy to maintain, or it is not very easy to still go through, because it is actually huge. So again, you need to do repeated analysis or repeated searching for those documents, so that you may able to sort, or you may able to remove the duplicacy, or you may able to select the best one, most appropriate one. And finally, from those documents, you have to ultimately gather some kind of knowledge or wisdom. So this is the overall information retrieval life cycle, we can say. So basically, how we are moving, like we are having basically working at different levels. So we are working at a document level, then we are working within the document in terms of vocabulary level, and finally, with the help of that vocabulary, we are having a certain understanding to get established. So there are various levels of work which are very important to us to complete this whole information retrieval cycle. So how big data is going to help us, that I will talk later, but I think you can understand some very established problems. Like the problem is, there are certain query terms and there are certain document terms, and you know that these query terms means we cannot have some we cannot expect some narrow kind of query terms, because the users are too high and their expectations, their perceptions are also very different. So accordingly, they keep different query terms. And even in the repositories, since the document availability is also very high, so the document terms are also very full of variety. So basically, we need to match these two things. And this domain is very wide. So the overall objective is how to make these matching as accurate as possible with minimum delay or latency so that the particular problem can get solved. So this is the overall block diagram, you can say. Like, we are working in two domains. One is the query and second is the documentation. So the first task is like how to prepare the appropriate query and how to represent the appropriate query in such a way so that we can match that query with the specific representation of the documents. So basically, for that purpose, this indexing mechanism is very helpful. So if we are keeping our documents in, means we are already aware that if something which is in some systematic order, maybe in sorted order, so we can easily able to locate it. So the same thing is here. So what we are looking for in this particular scenario, we need to update our indexing mechanism according to the availability of the data, which is very huge in terms of size, or not only the size but in terms of various other aspects that I will discuss here. So that indexing mechanism is important to us so that we can able to solve the particular query as per user expectation. So there are few notations which are widely used in information retrieval and that can be taken in the aspect of big data also. So the first thing is document. Okay, so document can be any unit which we are data unit which we are referring, but there are still certain constraints. Like, if we are keeping the entire word as a entire book as a document, so that may not be a very good choice, because it is in means it is having a very large domain to perform various operations. Okay, so and we cannot limit the document in terms of a one paragraph or one sentence. So basically, we have to see like how to maintain the clear trade-off between precision and recall while referring the data elements in terms of certain document. Then there is another term that is known as term. So terms are basically referred as word. Okay, and then we have indexing mechanism. So indexing mechanism, we are already aware, like all the dictionaries are following certain indexing mechanism. And the purpose of using the indexing is to make these search operations fast. So this particular task is not an easy task, because since we are having a huge amount of repositories available, and since we are having various types of data formats available, so having a universal indexing mechanism to incorporate all data formats is not possible. So that is one challenge. And the another challenge is to get appropriate indexing mechanism so that from this huge data we can get the results as fast as possible. As fast as is also really very tricky task nowadays. So if we see the metrics part, like how to measure the capability of the overall information retrieval processes, so there are two terms which are very popular. One is the precision. It is the fraction of retrieved documents that are relevant to the user information need. And second is the recall. So it is basically the fraction of relevant documents in the collection that are retrieved. Okay, so but you can see that these two terms are very important because means both are of our interest. But the challenging task is how to make a trade-off between these two so that we can cater the user's interest, as well as we can also see the present context where the document numbers are too high. So this is something which is very challenging. Okay, so you can see this particular statement. It is very high that it is highly expected that precision is important even in the expense of the recall. So this is something which is very important to maintain. So most of the times whatever techniques we are using, we are trying to have a trade-off between precision and recall. As far as the data is concerned, like how the information retrieval mechanism is handling various data types. So basically, if we go for the text data, so most of the time the text data is represented in terms of bag of words. Okay, so so basically here we treat all the words in a document as index terms and assign a weight to each terms on the basis of their importance, and then finally we may able to retrieve. Okay, so here we assume that term occurrences are independent, document relevance is also independent, and words are well defined. So this is basically a common way of representing the text. So you can see there are various examples like what is the word. So any of these possibilities are expected. So basically the word means it is most of the time you can see that there are various varieties of languages which are available. So any of these possibilities we need to handle in terms of dealing with the information retrieval domain. So in any simple documents, there are means a huge collection of bag of words so that we can that we can extract. And after having this, then the actual task starts, and it is basically the domain specific search. So there are various models. So one is the Boolean model. So basically we write the query in most simplest way, that is with the help of certain Boolean expressions. Second is the vector space model. So basically it is a kind of free text queries where queries and documents are viewed as vectors. And third one is the probabilistic models where we rank documents by the estimated probability of relevance with respect to the information which is required. But again, these probabilistic models are having some problems related to the classification accuracies. Okay, so I'm going through a very brief introduction about all this. Later, you will see like how the big data ecosystem is handling these different models in very different perspective. So first one is the Boolean model. So here, since it is a very simplest way to writing any query, so it use the common Boolean operators, and most of the time we use it. So for example, like and, or, not kind of things. Okay, so as far as the retrieval is concerned, so given a Boolean query, the system retrieves every document that makes the query logically true. So it is basically like an exact match. Okay, but you can say that here we are not considering the frequency of the term. So term frequency is not considering. So there may be certain inefficiencies at this particular approach. Okay, so although we try to consider all possible bag of words or terms, but the word sequence is not well addressed here. Okay, and it is all depending upon the vocabulary which we are creating here, and it is all depending upon the way of associating certain weights. So basically, this may be a primary step while going for the information retrieval process, but there are many issues which can raise more attention towards its weaknesses. So you can see this particular example, like we have the documents like this. So there is a document 1 and document 2. It is having multiple terms, so we have prepared the list of terms in such a way so that every term can be referred in the documents. Like here we are taking only 2 documents with the help of 0 and 1. Okay, and some of the things we can filter out as a stop word list. So you can imagine the situation, like since this diagram means this pictorial representation is the very simplest scenario, what is actually going on. So in actual situations, the documents numbers are too high, and if we are preparing this kind of table, how sparse the entries could be. So handling these sparse data is really very difficult for some, you can say that some basic methods. So how to handle this sparseness is really very important to address. Okay. So basically, there are various way to write what maximum we can do here. We can prepare our Boolean queries in more efficient way, and then we can see that how these Boolean queries are helping us to address the particular search requirements. Okay. So if we see the strength and weaknesses, so strength can be the its simplicity, strength can be its easy adaptation, and strength can be means you can prepare your queries very fast as per your understanding. So if we see the weaknesses part, so even we are very much familiar with the Boolean expressions, if we thoroughly check for some complex search operations, showing all the constraints with the Boolean operations may not be very easy. Okay. And sometimes these Boolean operations fail in because of various variations in the languages. So sometimes it is not capable enough to handle the language level variety. Okay. And the third important thing is, like, whatever you will get as a result of this, there may not be any specific ranking or some kind of positioning, so that means it is not going to guarantee the quality part. Okay. And sometimes it is also suffer with this partial matching related issues. So these are the problems where this particular approach is not very efficient. Then there are another one, like can we have some ranked retrieval? And you can see that in present scenario, everybody is looking for the retrieval kind of thing, where we are not only looking for the information, but we are looking for the most relevant information. So basically, here we estimate the relevance, and then we sort the documents by relevance, and accordingly we show the result. Okay. So here, as per the user expectation is, users want to see the best results. Okay. And then as per satisfaction level, maybe first 10, first 20, he can assume that whatever was the best, that is already explored, and later it is easy to decide the stopping criteria, especially for the search. Okay. Now, but the question is, like, although it seems very good idea to organize the documents in terms of rank, but how we can calculate the rank or relevance? Okay. So and even how we can calculate this rank or relevance, where under the scenario of big data, where the data size is in terms of exabytes. Okay. So so yes, if we go with the very simple understanding, so how we can make means how we can assume that a document is relevant if that document is having most of the query terms. So if it is exactly matching with the query terms, so we can understand that this document may be relevant. Okay. So this is the way where we started, but still we cannot say that, like, if we are comparing two documents in terms of relevance, so deciding their position is still a very tricky task, because there are a lot of computational overheads. So basically, there is a very established technique, that is vector space model. So we assume that documents that are closer together in vector space talk about the same thing. Okay, so therefore, the relevant documents we see in terms of their closeness, and according to the closeness, we create their some kind of ranking. There are another possible techniques, like we can calculate the similarity matrix between the two documents, and according to the similarity matrix, we can use this vector space model to decide their closeness. So here we are not using the Euclidean distance, but we are trying to calculate some kind of angles between the vectors. Okay, so this angle can help us to decide their closeness in terms of representing certain information. Okay. Then there are few more techniques, like one is the term weighting. So term weighting is basically, we try to explore how important the term is in this document, and that can be at local level, or if we talk about at the global level, so we try to calculate the importance of the term in the overall collection. So again, you can see that if it is at local level, then it's a really lightweight process. But whenever we are talking it in the global levels, then definitely lot of processing issues are important to be addressed. Okay, so and since there should be certain weighting mechanism, so that finally we can extract some meaningful information. So there is a very common intuition that is in practice, like we assume that terms that appear often in a document should get high weightage, and terms that appear in many documents should get low weightage. So accordingly we try to retrieve the information. So for that overall process, we follow a mathematical set of calculation or metrics that is based on statistics. So that is called as term frequency and inverse document frequency, TF-IDF. So it basically help us to understand how important a word in a document within a particular collection or corpus. So term frequency is basically a local term, and inverse document frequency is a global term. Okay, so basically for weighing factor, we use this particular formula where we consider the weight that is assigned to term I in the document J, and then we also calculate the number of occurrences of term I in the document J, and then we see the total number of documents in the entire collection, and also the number of documents with the term I. So with the help of this, we can able to calculate the TF-IDF weightage mechanism. Okay, so once this weightage mechanism is available, we can prepare the TF-IDF list, and this TF-IDF list preparation can represent the whole repository in some systematic way. And with the help of this kind of indexing mechanism, we may have more clear idea about the whole process. So basically, whatever paragraph will be there, and according to that paragraph, we may highlight all the words, and then we can see like whatever the documents we are retrieving, and we can calculate the term frequency in each document, and we always calculate the IDF factor for that, and we can rearrange the whole TF IDF representation with the help of an indexing mechanism. Okay, here what is the problem? The problem is, like, whatever these simple examples I am showing in this slide, it is not the actual scenario. In actual scenario, we are dealing with unlimited number of documents with full of means words. So basically, even for this small indexing mechanism, there are a lot of processing limitations. So how to make that more accurate, how to avoid the latency, that is really a challenging task. So here I advocate the use of big data tools so that we can make it more faster as compared to the conventional way of doing this. Okay, there are various other algorithms like scoring algorithms. So these scoring algorithms are also help us to score the topmost documents with the help of certain weightage mechanism. Okay, so if we see like how to make this overall structure available to us, so there are index structure and term document incident matrix phenomena. So here you can see that we have to prepare the list, and then we have to prepare the list of words, as well as we need to prepare the list of documents, and we can see that how these words and documents can be related to each other, and that can be shown with the help of a matrix. Okay, and you see that even in this simple example, it seems very sparse. So what would be the actual scenario? And if this is the only way to perform, how we will eliminate the computational overheads with this kind of sparse matrix where we have to really decide like what to do with these zeros. Okay, so there are various methods which are helpful to eliminate such kind of overheads. So basically, we first prepare this inverted index. So for every word, we try to make a list of document ID or a document serial number, so that we can understand like how this word is popular in terms of these documents. Okay, so in this way, there may be certain indexing can be done, and that indexing can be shown in the part as a part of dictionary. So basically, this is the very common process where we use some kind of tokenizers. So tokenizers are nothing but it is going to identify each and every token stream, and then accordingly we have to also see the various linguistic models so that we can match the most appropriate tokens, and we can collect all the most appropriate tokens together. And once this collection is ready, then we can specify any indexing mechanism. Okay, so this is the way how we could create this kind of indexing. And uh, and again, I can say that all these steps, they are having processing requirements. And since these steps are there are a lot of possibility that we can do it concurrently. So having a very powerful distributed platform is one of the common requirement for all these types of steps. Okay, so for example, like if you are trying to generate the tokens with these unlimited documents or with these unlimited size of repositories. So how these tokens can be generated efficiently if somehow we may able to distribute the process in various computational nodes. Okay, so in this way we can have this tokenization process. And similarly, you can see like this tokenization process is very much language specific. So if we talk about various language specific parsers, so even in the same document, if multiple languages are there, so we may need different language specific parsers. So parallelly executing this language specific parsers may help us to retrieve the data or the information with low latency. So that is also one of the aspect where the big data analytics tools are going to help. Okay, so similarly, if we try to drop some of the common words, that is the stop words, so that can also be helpful in terms of various steps. Like we can short the terms with the help of collection frequency, and then accordingly we can identify the most frequent term. And so basically uh, these all processes, you will realize that since they are very small, means they are simple tasks, but they are more in terms of its repetition or number, and they are independent also. So these tasks are independent also. So there are a lot of opportunity like how to make them more efficient if we could able to run them in a distributed platform, or if we can able to run them concurrently, if we can able to make a independent processing, so that it could not be a kind of overhead or a kind of pipeline process for the complete process, means for the complete task. So that is something which is a motivation towards thinking about big data tools for this information retrieval steps. Okay, so there are other hurdles also, like whenever we go for the normalization process. So normalization process means there are different standards, there are different linguistic standards, there are different standards in terms of location specific trends and all. So basically here we are doing some kind of matching so that we can keep them in common, in a common category. So so that is also required lot of processing in terms of stemming and lemmatization, so that we have to see how we can make it parallel. Okay, so although this vector space model seems very easy in terms of calculating the similarity, but still we can see how we can use different similarity measures as per different types of data formats, so that collectively we can able to come up with some fruitful results. Okay, so I am just taking one example, a very simple example, like how we are dealing with this type of information retrieval task. And then with the help of these examples, I will try to try to demonstrate how these big data techniques like Hadoop MapReduce is going to serve the purpose. Okay, so basically what we do, there are various ways, like sometimes we go for the Boolean query matching. So Boolean query matching may be with the help of some Boolean operators like and or all. So any document can be retrieved together because of this and or criteria. Okay, then we also see the matching in terms of similarity. So suppose if we have taken the cosine similarity, so we can see that there may be several documents, they can come together with the help of this. Okay, so so you can say that these are the light word processes, but they are unlimited in number. So how to deal with these important steps like cache folding, tokenization, stop word removal, and stemming in a concurrent way, what at the maximum possible extent, so that we can eliminate the dependencies of one term with means one step with another step, and so that we can address it with a minimum time. That is really a challenging task. Similarly, for stop word removal, so you can say that it is a process where we try to eliminate all those words, and it is not dependent to means if we are dealing with the large corpus, so that large corpus means it is not something which is a very means we don't need to manage it at once, so we can do it concurrently, we can do it in a distributed fashion, we can divide the task in multiple processing elements. So these are the tasks where there are a lot of possibilities to use the distributed environment for better efficiency. Similarly, if we talk about the stemming word, so stemming is also an independent process where we try to see the base word. So even if we are trying to if we are suppose retrieving the data from any document, so that word that line by line retrieval or paragraph wise retrieval, the stemming can be done separately in isolation. Basically we have to see that here how we can make a program where this stemming process can be done more accurately in some concurrent fashion. Okay, so basically if, we have already seen that we can prepare indexing. So indexing mechanism is also needs means whatever documents we are retrieving and whatever words we are focusing, accordingly we prepare this indexing table. So there are different ways, like how to make this overall uh, indexing process so fast, so that we can eliminate this latency part. So here also a lot of efforts means can get reduced if we are using some big data ecosystems where the distributed processing can be the first facility or the first thing which we can get. So I have taken one another example, like these are the four documents, and these four documents we are trying to index. And you can say that out of these four documents, the indexing is actually the word wise. So there is no harm if we are doing it in some distributed fashion. So when we are doing it in a distributed fashion, the same thing can be done easily, and later we can retrieve our results and merge our results for the clear picture or the complete picture. So there are possible ways, there are many possible ways where most of these information retrieval steps, rather than doing it with one processing element, we may dynamically create various nodes so that they can do the task parallelly, and to eliminate the delays and to come up with more real-time processing and with better accuracy. So this is again the way, like how we can do it in terms of parallel thing, like we can take every word separately, and finally we can merge these words if they are required together. So that is all about the IR basic steps. So what my idea is, like since these IR basic steps, they are not a very what you can say, that computational intensive task in terms of at unit level, means this if we are focusing on one task, so it is very light. But since we have to handle maybe millions of these kind of tasks within a fraction of microsecond or millisecond, so that is actually very difficult. So here the main issue is basically the scalability part, and here the main issue is the reliability aspect, where the application is important. So what my observation is, if we are using these small means if we are using big data ecosystem for these kind of small tasks, so that create the overall system more robust, more useful, and more efficient for many of our real-time applications. So basically, the purpose of this particular lecture is to convince everybody, like with the help of good big data, whatever big data systems ecosystems are available, we can make it more robust, we can make it more efficient. So that was all about the scope which I am considering for this particular presentation with respect to information retrieval part. Now I am coming to the big data aspect. So as the title indicates, like I have quoted that how we can do this information retrieval in two paradigm. One is data at rest and second is data in motion. So let me explain these two terms. So I think we all are aware that data is coming from multiple resources. So this is the present picture. Yeah, like data is coming from RFID tags, data is coming from mobile phones, data is coming from GPS devices, data is coming from web sources, and maybe with the help of smart meters, maybe all social media platforms. So all these are basically the source of information. So they are basically nothing but means it is a collection of words which we are getting with these kind of resources. Okay. So what are the IR challenges in big data perspective? So although there are two challenges, if we talk about the big data aspect, so definitely there are big data challenges where we see, like means the management of this overall means you can say that data is really very difficult. If we see the information retrieval aspect, so it is all about interaction, it is all about business intelligence, or it is all about sentiment analysis. So basically we are, as per information retrieval aspect, we are looking for its means end uses. So end uses can be anything. End uses are basically to serve some business intelligence expectation, and uses maybe efficient use of social media platforms so that we can do some sentiment analysis. So it is basically challenging in both aspects. So how to support the challenges of these two domains, if we are clubbing these two areas for some common purpose, that is important to understand. So if I talk about the big data concepts a little bit, so that you can see that how the information retrieval scope has been widened nowadays. So let me show you the V's of big data. So you can see the first V that is very commonly acceptable, and we are very much familiar since long, many years, many decades, you can say, that is the volume part. So whatever data we are having, our prime concern is about its size, about its volume. Okay, and whenever we are considering this aspect, we assume that data is at rest. So here, all the data is available to us, and we are free to perform any operation sooner or later as per our convenience, and that operations can be repeated and we can repeatedly modify our means policies, and finally we may get some information from that particular uh, set of document or some that particular set of data. So I can say that information retrieval steps are easy if we are working in this particular domain. And whatever I have explored, I found that out of means whatever complete research are available in the domain of information retrieval, I think 70 to 75% research is limited with the consideration that data is at rest. Okay, so that is something which is a very interesting pattern. Then what about the next one? Okay, so you see the another V, that is velocity part. So if we consider this velocity part, so we are assuming that the data is in motion. So data is in motion means data is arriving at a very high speed to us. And you can imagine any simple scenario, like suppose there are suppose we are doing some Twitter analytics or social media analytics, and we are using Twitter platform, and for any particular announcement or post you want to calculate the sentiment. So you can understand if it is a Twitter analytics platform, if it is a Twitter platform, and if you are trying to grab the sentiment, how dynamic this complete model would be. Means anytime you can see the post which are means which are leading for one kind of sentiment, and maybe within a fraction of second you can see that because of some other post the sentiment, the prominent sentiments may be something different. So basically that is the situation where we consider data in motion. So when we consider data in motion, so we assume that data is in stream format, and we are receiving millions of records per second, and we need to respond it immediately. So if this is the case, then the whole situation means the whole scenario or the complete process of information retrieval will become more challenging, because we have means we need to respond immediately, and this response system is very dynamic, and whatever we are doing we need to repeat it again and again. So maybe with new data samples you have to repeat it again and again, and every time the document means the term frequency is changing, the document frequency is changing. So whatever means whenever this data is in motion, the whole system we cannot design at once, but it should be adaptive in nature. So that is something which is very important to understand. Then third part is the variety part. So we all are agree that right now whatever information we want to retrieve, these informations can be thoroughly understood if we are open for various data formats. Like sometimes you learn through words, sometimes you learn through images, and nowadays it is very important if we can able to see some videos of that particular context. So whatever is not clearly explainable, with the help of text and images, that we can easily understand with the help of videos. So basically that is more informative. And similarly, even if we talk about the text, so there are various way of representing the text. So basically all those things are highlighting the variety part. So we have this structured data, unstructured data, multimedia data. So how to handle these many multiple formats data for basic objective of information retrieval, that is getting some information and or knowledge from the huge repositories. So that is really a challenging aspect nowadays, and that is something where lot of research is already going on. Then there are other V's also, like one is the veracity part. So veracity part means there are data which are always in doubt because of unlimited sources, because of high speed, or because of very fast generation. There are uncertainties very obvious, and the uncertainties may be in terms of inconsistency, in terms of incompleteness, uh, in terms of various other ambiguity, in terms of latency or delays. Like if we are observing certain repository for some information retrieval process, and if it is coming from varied sources, so sometimes the occurrence sequence may differ, the generation rate of the document may differ. So at any instance t, whatever you are observing, that may not be much relevant for any instant t plus 1. So these are the things which are important. Similarly, the visibility part. So visibility part means since we are having information retrieval task very commonly used, but because of this ample amount of data, that visibility part should be also well taken care, and we have to see that how to maintain privacy and security for the information which we are dealing under the aspect of visibility part. Then the last part is the value part. So we have to see that ultimately we are retrieving the information to have certain value. Okay. And you see that this value part, if we talk about this current scenario of big data, it is something which is very what I can say means it is variable, it is full of variation. So at any time, whatever value you identify, maybe the next time instance that value become means unimportant, or it vanishes, and the new aspects can represent the value of that particular data element. So how to make the whole process more context specific, so that the value part can get addressed, or the value part can get satisfied, that is really very important if we are dealing with this under these present situations. There are other V's also, like variability part. So variability means the data or the documents or the repositories which we are managing, they are constantly changing. Okay. So so this changing means this change is something which needs all the models to be very, very adaptive. So that is very important. And then the viscosity part. So viscosity says that every document, every information, whatever is available to us, it is having certain time span or life. So maybe anything after certain period of time may become useless. So we have to see that viscosity part very prominently. So how to generate more and more information with this viscous means viscous nature of the data. So that is important. Last few important concerns are the virality part. So we have to see that means can we uh, calculate or control the virality related index with the help of information retrieval techniques. And so basically that is something we have to see, because this has become very problematic nowadays. Like whatever data it is available, if it becomes viral, so whatever information retrieval techniques you are using, see they can become means a poor performer because of the repetition of same data again and again. So it is just wastage of processing elements, processing power, and this virality is a kind of threat for the typical conventional information retrieval systems. Similarly, the volatility part. So volatility speaks like see, we are not having the context aware information retrieval techniques very means very established. So this volatility may also increasing useless overhead with the information retrieval systems. So basically what I want to speak here, like whatever data is of purposeful at any particular time, it may become means an overhead after some times. Like you see your mobile storage. So if you are keeping some data maybe important for today, but tomorrow it becomes obsolete, and in this way your mobile is means full of storage. The same thing is here. This is the situation of big data, where we are generating huge amount of data every hour. So how to handle this volatility part, means when to delete, how to delete, to support the uh, information retrieval processes, that is important. So basically we need to synchronize these policies together, so that the overall information retrieval processes can become less overhead, or can become more lightweight for final objectives, or for the purpose it is going to be explored. So these are the scenarios where we need to expand the information retrieval capabilities. And as I already told you, like most of the research is with text only, but we cannot deny that we are only exploring the text part nowadays. See, most of the time the students and the researchers, they prefer video documents more as compared to the textual information, textual details, because the video is easy to understand, and maybe it is crisp also. And so how to use this information retrieval over video data, it is really a challenging issue these days, and it is means it is coming as an emerging area of research. So I am moving forward in terms of the conventional examples, like the text only examples right now. Like if we focus only on the text based repositories, so you can see that the data can be structured like this, and this may be the best case, because we are already having well established techniques to handle these kind of organized data. So it can be any structured data, maybe relational databases, okay. And sometimes the unstructured data. So this is the typical domain where the IR potential can get explored. So here all the output which is returned by the Google search can be unstructured type. And luckily we have semi-structured data types also. So these semi-structured data, for example, an XML file. So basically whole repository, we can assume that it is full of either structured or unstructured type of data elements. And the question is, like we cannot say that it is means we cannot expect the variety, means the difference in terms of performance, if we are dealing with the text data, or in terms of structured, unstructured, or semi-structured. So there should be certain ways, so that even whatever is the case, we may able to get the equal performance or comparable performance for all such of information retrieval stages. Now I am coming towards the most challenging part, which is because of this big data we are facing these days. So that is basically the velocity part. So velocity part means whatever repository, if suppose we are considering a text repository, and this text repository is nothing but any web based submission system, you see that data is not coming all at once, okay, and data is coming on a real time fashion. And even we have no time to wait for the complete data to be arrived. So certain applications are there where we need to respond immediately based on whatever we have at that particular time. So this is the concept of data stream. So basically most of the time data is reaching towards in terms of stream. So what is a stream? Stream is an ordered and potentially infinite sequence of data points, okay, and we represent mostly it in terms of vectors. So any example such as real-time aviation data set, or your Uber or Ola app taxi data set, where you can see the latitude, longitude of any particular vehicle which is reaching to you, or maybe your train tracking system, where you can see the position of your train with the help of some data. So basically these all are streaming data, and you can see that it is updating in every second, or maybe fraction of millisecond, or maybe fraction of microseconds. So basically to process this data for any particular information generation is a very, very difficult task. Okay, so what are the difficulties here? If we talk about the typical scenario, so the management of this repository itself is a very difficult task. So suppose if you are collecting or documenting from where you have this particular information retrieval process, and this document is nothing but it is
Yes,
coming as.
ma'am. Actually, the voice is just disturbing your audio. So I don't know the reasons. Maybe because it is getting distracted.
So should I
Yes.
reconnect?
Either
Let me
can you switch off the video, ma'am? Is it possible? Your video.
sorry.
Can you switch off the video because maybe because of video it is taking bandwidth. Your audio is cracking.
Okay. Video is already off actually.
Yeah, it's okay. So I don't know where I don't know how to recover. It's
Okay.
audio is disturbing. So maybe
I am
somewhere because
reconnecting.
till
Yeah,
now it was fine.
actually there is a network problem.
Yeah, still now it was perfectly fine. Just to 1 minute back it was started.
So let me.
It's fine now, ma'am. Ma'am, fine. It's fine.
It's fine now.
Yes, yes, fine.
Okay, so there was some data. Uh, means I think there was loss of connection. So now I can see. Okay. So okay, let me continue from where we lost the connection.
Yes.
So yeah, so I was discussing this important aspect of big data, that is data streaming. So basically this data streaming applications are very commonly used nowadays, and it is really challenging to retrieve the information from data streams. So data streams can be anything, like data streams can be your travel app data, as I have already told you, like whatever you are using, maybe Uber or Ola app. So it is showing the latitude and longitude of that particular vehicle which is reaching to you. So it can be anything, or maybe your train status data where you are just checking the status of train where it is. So that can be basically the data streaming part. So now the question is like how efficiently we can retrieve more and more information for from these kind of platforms or from these kind of repositories. So let me raise some other issues also. Like first we need to manage all the resources. So here the challenge start from here itself. Like whatever data is coming, that data is generated as a result of certain events. So events can be for example, like you are having some scanning of your luggages in any security gate. So these luggages are basically going for some scanning purpose, and according to that video captured or some pictures taken, or maybe some machine learning or some image processing tool, they are getting the data, and then according to the data they are doing some matching, mismatching, and finally they are coming with some results, maybe appropriate classification, like the particular item is allowed or not allowed. So that is a typical scenario where the streaming data is coming. So it is although it is in terms of images, but there are many scenario where we are dealing with the text itself. So since data is coming from various sources as a part of event, so how to make a common repository for all those sources, that is important. And after the information retrieval complete process, whatever we respond, that is also means the response should also be not only to select something and displaying something. Sometimes it is not only the simple search, but to automate certain actions based on that search. Okay, so and that actions can be means any event. So basically we are taking data from the events and we are generating our results as a part of event. and since it is all going to happen in the real time fashion, so latency is very small. So maybe we have to complete all these processes in the fraction of milliseconds or microseconds, and we are basically dealing with millions of records per second. So that is the present situation where this kind of overheads are very obvious. So the challenge is how to handle all those overheads. Here I am showing one another scenario so that you can realize the challenges for stream computing. So if we are dealing with the information retrieval process over the streaming data, where the data is coming from varied sources, and you see it is not means it is not mandatory that these all data is generating at one speed. So there may be different speeds in terms of data generation, there may be different formats in terms of data acquisition, and so how to perform this continuous ingestion, that is a challenge. Then how to fuse the data if they are available in multiple formats, and how to fuse the data to preserve their valid order if they are coming at different temporal constraints. And finally, after doing all these IR processes, how to present the results or observations within the fraction of microsecond. So these all situation is really very challenging. Okay. So I'm going to give you the idea like how these two approaches can be different, like dealing with the data when it is at rest and dealing with the data when it is in motion. So I think these two terms are clear. If data is at rest, means we are having our repository with us and it is available. And if data is in motion, then definitely the repository is continuously growing or continuously updating. Maybe we are losing some past information and we are getting some more and more relevant documents, so something like that. So for that, let us understand few other characteristics of data streams. So data streams are basically continuous ordered sequence of data, and it is changing in nature, and it is again of huge amount, so that is important. So it is coming in terms of huge amount. And traditional database management systems, basically the data are in finite in size, means they are having some limitations. Okay. So there are few issues, like if the data is reaching to us constantly, so anytime we will not claim that we are having the clear picture. So maybe we are having the partial information, and since we are having the partial information, whatever we are observing, that may not be a, you can say that a ultimate observation. So definitely we need to update it very frequently. So that is basically important. And since the data is reaching to us in so faster manner, so whatever data we are handling, it is very difficult to store it in some secondary devices because of the latency issues. We need to respond immediately. Even sometimes we are not having any time to organize it or store it or making some indexing. So means it is a very quick process, you can say. So how to make the use of random access memory itself, so that we can make it more and more faster. And you know that random access memory is expensive. So it is basically a single scan algorithm. So whatever we have to do, we need to use a single scan algorithm for the overall process. Okay. And later, if it is required, as a result of information retrieval, definitely we need to present some summary, certain understanding, some concepts, some context, and that we can save for the further purposes. So this is basically important aspects. So what you can say that most stream data are at pretty low level or in multidimensional in nature, but they need multi-level and multi-dimensional processing. So we have to make our IR process so robust so that it can work on multiple dimensions. So I am just giving you one example of the two situations. First one is when the data is at rest, and second when the data is in motion. So if data is at rest, So actually we are doing the batch processing. Okay, so they are high latency apps, there are static files, we can process it after storing, and most of the batch processors are efficiently doing it. So there is no as such means there is no urgent need to do something very prominently here, means it is already established nowadays. But we, if we are doing the information retrieval with the streaming data, so basically these are the low latency applications. Most of the time they are the event streams, so most of the time you see the data is generating with the help of certain events, and as an output we have to again invoke some further events. And the here the idea is to sense and respond immediately. So here the typical batch processors will not work, so here we have to deal with some of the stream processor engines. Okay, so and the another there are, although there are many differences, but I can focus few important differences. Like for these kind of streaming data, the information retrieval processes can be executed only in the main memory, so there is no time to store in the secondary memory. Okay, and we have to make our indexing mechanism in such a way so that it can grow over a period of time, and that growing should be efficiently handled with the help of that limited main memory. So do we need to use some kind of forgetting mechanism so that previous data we can forget, and means previous documents can get vanish and new documents can come to the picture? So there are many issues which we have to see. Okay, so basically we have to see how to handle these data variable data arrival, which are completely unpredictable and which are having full of uncertainties. Okay, and so basically these are the things where we means the whole data management strategy or information retrieval processes can differ. So one is when the data is at rest, and second is when the data is in motion. Okay, now I am giving one last idea, means a concept which may be enough to proceed further at this stage. That is the windowing concept. So windowing concept means, although means in a typical information retrieval process we assume that the repository is available to us, how in streaming we can limit the arrival of data of maybe for fraction of seconds, so that at least with that instance we can work, or we can start our further processes. So that is possible with the help of windows. So windows are basically a way to extract finite relation from the infinite stream. So basically we collect some snapshot, you can say it is a kind of snapshot, where although the data is infinite, we take a one snapshot of the data and we focus on that only. So there are various ways of creating the window. Can we create the window based on the ordering pattern, means in terms of their arrival? Can we create a window simply based on the count? So every 10 count maybe one window, so we whatever in IR processes we have to do, we will focus the first 10 availability of data or whatever or in document, and we can do it. Or can we make some other issues, like if we are getting text in a very running format, so we can make some punctuations like full stops. So if there is a full stop, we can focus on that only at a time. Or if there are some paragraph change, so can we do it at the paragraph level? So there are different ways of creating the window, so to generate the idea of window. And there may be some variants also. So variants, maybe we can partition the tuples in the form of variants. So this is the way how we decide to perform this
I think we lost. I mean, your audio is not available to us. We maybe, yes, it is fine. I think it is. I mean, it is available. Yes, ma'am.
Yeah, I can
Yeah, it's
listen you
okay.
properly.
Yes, yes, it's okay, ma'am. It's available.
Okay. Okay. I think there are some poor network issues.
Yeah, yes, ma'am. Yes. So
Okay. Okay.
so if you say, I mean, we can take a break here and we'll continue in the next session because we have got few questions from the participants also.
Okay.
So
Okay.
it is
So
up to you, ma'am.
okay, fine. So we can take a break, and then maybe because of the network issue, I will also see what is going on.
Yes,
So
yes, yes,
let us meet again at 12:30, and
yes.
I can refer the questions here, and maybe
Right.
in the next session I may able to answer all those, and then
I
we can
think
proceed.
ma'am, these questions are related to only the very fundamental aspect of IR and
Okay,
how
okay,
we
okay.
have
Let me
discussed the
check.
basic steps. So one
Yeah,
of the
yeah.
question which I prefer to raise that in stemming and removal of stop word can sometimes impact the sentiments. So how to handle this issue? So more often that whenever we process it, so we lose sentiments of the text. So how to handle this is, ma'am? So this question is from participant Vandita Grover.
Okay, okay. See, if I am taking the data analytics perspective or a machine learning expert, so it can be handled if through the learning mechanism only. So it is all depending upon how we are making our learner strong, so that it can be more familiar with these sequences, these occurrences of words, and accordingly it can learn. So I think it is the learner's capability to address this particular situation.
Right, ma'am. And there is this specific question from the participant, Dr. Mrityunjay, says, uh, in case of IR, which model is suitable, a vector space or BERT model? So can we,
Uh,
I mean, have this look between, I mean, comparative view?
Yeah, so see, I would prefer this BERT model. Like this is the era where we are dealing with unstructured data. So through transformers or through deep learning mechanism, this BERT model is now very powerful, which can not only handle the text part, but also it can retrieve the text from the various other formats. So I think this vector space model is conventional model. It is good for a typical scenario where we were expecting only the text repository. But nowadays the data is becoming more and more unstructured. So if we see the social media platforms, the Twitter-like platforms, so that BRT models, they are really performing well as compared to the VSM model.
Right. Yeah, so I think it is sure. And there is a question from participant Prakash Hegde says, tools now, so model tools like Grammarly are changing the structure of the documents or text documents. They don't allow to repeat similar words and also recommending new sentences structure. So what consequence can we look out for? So I think this is something related to the restructuring of the document and its effect on the pre-processing steps in IR. So,
Yeah.
ma'am, what is your take on it?
See, if like these are the kind of pre-processing part where we have to means see the restructuring of the document part. So basically, what I want to say, the typical indexing mechanism which we followed earlier, they were uh, uh, they were not sufficient enough to handle these duplicacy part. So but now because we have the experience of map reduce processes, so these map reduce processes, they are very well handling these kind of duplicacy part and paraphrasing part. So basically they are means we are running in different aspects. So one is that structural representation of the whole situation, and the second one is making that more contextual in terms of understanding the value and repetition. So I think with the help of better indexing mechanism, we can solve this problem. And the Grammarly tools, and there are many other tools, so they are working in both ways. They are not only using the indexing part for faster retrieval, but they are also using some cognitive processes so that they can understand the meanings of all those things in terms of duplicacy or in terms of the particular context.
Yes, right. So I think it is well addressed. So With this, I think, ma'am, we can close this session. If any participant is having any specific doubt, we can hold that doubt for the next session. One particular question I want to raise, ma'am, with you. So, like in the very first day, also it has been raised that getting the relevant document in the retrieval process or in the retrieval system, getting the relevant document. I mean, because relevance, defining relevance again is challenging part. So, to
Yeah.
getting the number of relevant documents or identifying the relevant documents, the challenging task. So
Yes.
what are the possible best practices for that we can have in a system?
Okay.
Yes, ma'am.
See, if we means there are actually various areas of research. So if I need to answer it as a data analytics expert, so what I will say, like the more rich corpus we will use and the faster way we process, then the better relevancy criteria we can identify. So basically, it is all about the maximum inclusion of corpus, as well as it is all about the uh, quick distribution of these corpus among various nodes, and then finally getting some relevancy score, and that relevancy score can be uh, taken together to get the best one. So basically, I can answer it in a computational point of view. So the methods are actually the same. It becomes challenging if the size is too high. So if as far as the size is concerned, we can handle the Hadoop MapReduce ecosystem, where not only we are performing the distributed computation, but we are also having full of these many machine learning aspects, so that over a period of time the system is becoming more and more robust. So I think with the help of this we can have our efficiency better over a period
Yes.
of time.
Yes, ma'am. So yes, there is a last question we should take. I mean, if possible, by Siddharth Ravindran, one of the participant. In video streaming applications, what are the pre-processing can we do? We can do. I mean, so
In video streaming applications, finally, we need to break the videos in terms of number of frames, and then finally, we have to identify various objects and their temporal dependency of the objects. So basically, whatever objects are there, maybe these frames are changing over a period of time. So their temporal dependencies is really very important. Then only we can establish a proper sequence, and after having that object and their temporal dependence, then we can go for fine level details, so where we can see like how the objects are differ from each other. So main important issue is identifying the objects and their temporal dependence which with respect to each other.
right. So with this question, I think we can go for, I mean, conclusion, at least for a small break for this session, and we will be joining in the next session to have a detailed, extensive idea on stream data analytics or stream, how we can perform a retrieval on a stream data. Thank you, ma'am, for this session, and we will be resuming the discussion in the next session. Thank you, ma'am.
Okay, okay,
Yes, thank you.
okay. So we'll meet again at 12:30.
Yes, ma'am.
Thank